Hello there, it's ToadBearGrin4 here with a redstone video this time. So this is going to be a little bit different than what I usually do, starting with the fact that it's not Far Cry. But I was asked to figure out a piece of redstone. So, sorry about that, I didn't mean to peek my microphone. So the idea is that you have different keys that you can drop into a chest, and then it calls a minecart chest corresponding to that key. So this is what I've done here. So I've got 8 different keys, and all you do is you take whatever key you want, drop it in, give it a few seconds to process and send, and I believe I just requested 6. What a great example. Wait. I don't know how that got misaligned. Let me try that again. Yeah, sorry about that. Normally that wouldn't happen. I guess I was experimenting with the design, trying to make optimizations, and something happened to misalign it. But it should work fine now. So let's try 6 again. There we go. Much better. So you can see that called the chest corresponding to 6. I put whatever I want into it. Sure. Put whatever I want into it. And then send it back. And now it's nice and safe in the redstone. And then it resets the redstone after it. So that is no longer tripped. And that works using a reset line sent from here. So pretty much the way that it works is, let's drop in 7. See, what happens is when 7 triggers, it moves the redstone block to here. This is just a memory latch with the reset line right here and the active line right here. So sends that, and that causes this to be the only line to be off, which lights up this torch, which then goes in through here. And because of where it is in the cycle, like if it was before this minecart touched here, then this redstone circuit here would actually be off, which then lights up everything to the left, giving the cart a straight path back. Now if I were to try to return it like that, like send the cart back, then it would get caught in the first chest. So when it hits that, it toggles this T flip-flop, switching the direction of the track and making it so only this line is lit, giving it only one path to return to. And as you notice, even while it's sitting there, this memory latch is still active, so that memory is still valid. Now when I return it, you will see that it actually takes a different path that lights the reset line, which you can see firing right there. and all it does is it resets every memory latch. It only needs to reset one, but since only one will ever be lit at a time, it's no problem that it resets all of them. It's just a little bit noisier, but luckily this is a large enough of a design to where, yeah, the size actually benefits it because you don't hear any of those pistons. The minecart is the only part that you're likely to hear, unfortunately, but anyway, on to the tileable part of it. So I designed this and got it all working, and then I made a few refinements and made the tileable part. Now, it is tileable, however, to go beyond 8, every 8 that you need, you have to put a repeater right here. So, you have to put a repeater right there and then extend this rail to cover more. So, so let's start with the input. So right here, you have a basic item filter. The way that that works is you just put 20. Whoops, I have forgotten to finish that. Hold on. That just needs to go there, and need a torch. And then that goes right there. Sorry about that. So yeah, you put, I believe it's, however many that is. I think that's 21. Yeah, 21. You put 21 items here, and then whichever item you want it to filter for, right there. So it's filtering for 8. You can see that causes a pulse and pushes the memory this way, which means that it's no longer lighting this line. So this is all input. So the top line of the input goes and sends off the minecart. The bottom line of the input is the memory state. And you can see that that's no longer lit, which lets this be live, which flips this circuit, this rail here. Also lights this as well, which this is the bit of the circuit that lights everything to the left. And then this here is a reset line that just goes and resets all of the memory. So in an effort to make it tileable, rather than having one set delay and then having that work, putting a repeater before every single one actually makes it so you can build this infinitely and still have the right delay further along the track. Because of the time it takes for the minecart to return, there has to be a delay. So yeah, that's pretty much the design. So I'll just go through and slowly move around and show you how it's set up if you want to copy it. I'm sure there are optimizations that could be made. I'm just not sure of what they are. One optimization that was made just between building it here and rebuilding it is I was able to shorten the amount of track that you need just by extending this redstone line here, for example. I'm sure there's a more efficient way to do this part of it, but I'm not sure with what that is. So now that's the tileable part. You still need other stuff to make it work with however many objects you have, or no matter like how many of these segments you have, you still need a certain base structure to make it function. So the first part is a T flip-flop. Here I'm just using a dropper hopper T flip-flop that every time you pulse this block causes a change in whether or not something's in this dropper, therefore changing this output. So that just needs to have, that just needs to feed into a block and invert a torch. Or you can just put a repeater and have this work the opposite way, but a torch is cheaper than a repeater. So yeah, because obviously like this is inverting the signal from that. And if you wanted it to use a repeater, then you would just have this always on the opposite cycle. So, but I would do it this way. Then it just feeds along here, just like it's in the tile. Now, again, to do more than 8, every 8 you need a repeater. So if I wanted to build another segment of this, just slap a repeater right there and it would keep on going. Now, other than that, you have a couple of things that you need as far as the rail is concerned. So on this rail, you need a detector rail set on a 16 tick delay that feeds straight into this dropper. That feeds straight into this dropper right here. And again, that timing is just so Minecart has time to move before things start switching. So that just needs to feed straight all the way up to here. And this is where it stops. This is where you access it. So now off of that, you need this in the rail, this kink here. Because what this does is it makes it so the minecart will go straight up here and then actually get there. But on the return path, it's forced to take this secondary route. This secondary route is actually what controls the reset line. So you can see that this feeds down into a 1, 2, 3, 4, 5. That is a 20-second delay, or 20-tick delay, that feeds directly into the reset line, this pink line here. And again, that delay, this initial delay is absolutely needed to actually make it function at all, because if you start having the reset line fire too early, the result is it resets quicker than the minecart can get to it. Keep in mind, if you have this rail run elsewhere, which you absolutely can do, if you want this timing to work, you need to have the reset line still right here in the design of the actual redstone logic. Because otherwise what will happen is, like if you try to move this up, like with this, like if you want this to, instead of stopping here, you know, go way over here so you don't hear it at all, and are okay with the fact that it'll take longer for the minecart to travel, then, and if you move this with it, the end result will be that this redstone is going to move faster than the minecart, and by the time the minecart gets here, it will have already reset and dump it into the first slot here. So just be cautious of that, when you rebuild this, starting here is when you can move it wherever you want. Another bit of infrastructure that you need is this rail line here. So this rail line here just needs to make a big old loop back and forth. If you want it to be a little bit faster, what you can actually do, and I just thought of this to be honest, is, let me see here. Alright, hold on. Let me back this up. This will make slight speed improvements. What I'm doing. Just go ahead and put that there. Go ahead, and right here. There we go. That should be a little bit faster. And cheaper on rail, so that's always good. So actually, I do believe that is improved. So that's going to be an official change. Except for when I break this. Alright. Sorry about that, on the fly improvements. So yeah, that's all you need for that. You can increase separation by this, just by having the minecart go further. So like, again, if you want to move this back so you don't hear as much, of course you can do the same thing with this rail here. And of course you can go up with it, except you just have to be cautious that the minecart can actually go as far, like, you have to keep up with the powered rail to make sure the minecart can't go as far as you intend. So yeah, just keep that in mind. But other than that, that's really the basis of the design. Everything to the left of this block, more or less, you have to have set up just to start building the system, and then you can repeat this whole structure as many times as you want. Keep in mind that the response time is decent when it's 8. If you were to double that, it would take a little over double the time to get a response. So every time that you increase it by 1, you add a little bit more of a delay than you would expect. So like if it takes 10 seconds for 10 of them, then the 11th one isn't going to make it 11 seconds. It'll be like 11.1 seconds or something like that. Yeah, but that's how you build this. It's pretty cool, I think. I'm sure there's a better way to do it. I just haven't thought of a way. But anyway, thank you for watching, and let me know if you have any questions.